Math 96, section 8.6, elimination using matrix. We have introduced several methods to solve two equations and two variables: method of eliminations, method of substitution, graphing, and now this is another method of solving a system of two equations, two variables, or even three equations and three variables using matrix. So in this example here, you have two equations and two variables x and y. Using the matrix, we always deal with coefficient. Coefficients are the numbers sitting next to x and y, and also what you have on this side. So coefficient of x is 3, y is 4, and what you have on that side is 5. So we are dealing with all the numbers or all the coefficients to solve the problem using the matrix. In this example, we have written a rectangular array of numbers, such an array is called matrix or matrices. These are several examples. And the way it works with a matrix is you have, these are all the rows and you have all these columns. So for instance, this one, you notice there are 3 rows, 1, 2, 3, and 3 columns. So we call this 3 by 3 matrix, or like this one is 2 rows and 2 columns. So we call it 2 by 2 matrix. So like M times N matrix. The first one is the rows and the second one is number of rows and number of columns. So this one is 2 by 2 and this one 3 by 4. 3 rows and 4 columns. So it's 3 by 4. So that's how you call a different thing. Now, here, there is examples here how to solve it. What we're trying to do here is, again, dealing with all the coefficients in these examples. Our goal is to have, like if I want to write the equation for this one equation is see, for the matrix, I have this matrix of 5, -4, and numbers on the other side is -1, 2, 3, and -2. If I want to change the matrix to the actual equations, then you put the x here and y here, x here and y here. So then this would be equation of 5x minus 4y equal to -1 and -2x plus 3y equal to 2. Okay, so when you have a matrix of, let's say I have this equation, 3x minus 2 equal minus 2y equal to 7, and 7x minus 5y or positive 5y equal to 1. If you want to write a matrix for it, is 3 minus 2, 7, 5 or positive 5. You don't have to write a positive if you don't want to. And numbers on the other side of the equation you listed here. This is how you go from equation to matrix, and vice versa. If we have a matrix, which is again -1, 5, 3, 7, and you have 10 and let's say 6, something like that. If you want to change it to the equations, then you just say -1x or just -x plus 5y equal to 10, and 3x plus 7y equal to 6. Okay, so it's like you put the x here and y here, and equal sign and equal sign. That's how it works. Now, you could imagine if we have a matrix like this, Okay, let's look at this one. And I want to write the equation for it. Equation for this one is minus 2x plus 7y equal to 5. And now 0x plus 2y equal 4. Now, remember 0x, this is gone. So what you have is just 2y equal to 4. And when 2y equal to 4, y is 2. To solve a matrix, you need to have one of these 4 0. Somehow you need to work with the equations and have one of these 4 entries 0, because if it's changed to the 0, then when you write it like that, you have only one variable to solve. That's our goal when you're working with a system of 2 equations. So on that, let's look at one of the homework problems. This one is 6x minus 2y is 4, 9x plus y equals 16. Okay, I want to solve this equation using matrix. So our goal is to have one of these. First, I write all the coefficients. 6, -2, 9, 1, 4, 16. I need to change one of these 4 to 0. Then there are several ways to do it. One is, okay, you see how you have, if I multiply this row, which is R2, if I take this row and multiply by 2, everything by 2, then you have +2, and then you could add it to this to make this 0. So you take all the entry in the second row, multiply by 2, which give you these numbers. Then you take these numbers and add it to the first one, okay? So in that case, you have what? You have, when you multiply by 2, you get 18 to 32, and then you add it to the first one to come up with the new R2. So then you have the new R2 is this. Look, 24, 0, 4, and 36. See, now one of the 4 entries is 0. So when you write the equations, you just do not have any value here. So you find the x. When you find the x, you plug it back into this equation to find your y value. It's like very similar to method of elimination. See, so from the beginning, if I need to change one of these 4 to 0, I have to multiply this 1 by 2 and then add it to the -2 to make it 0. Then you could have that and put it on the first row if you want, or you could just replace the second row with it. In this case, we decide to have the second row, but make no difference. Okay, I can multiply everything here by 2 and then add it to the first row and then replace the first one. But here, what I did was I took the second row, multiply everything by 2, which I have these numbers, like these numbers now is 18 to 30, and then add it to the first one, and that give me the new R2, which is this. Which is this 3. Since one of them is 0, then you could solve the equation. We also have, or this is an example of the 3 ones. 3 1 is not, it's not that easy to do. You need to do a lot of work, and somehow after you do all this, you gotta change to the 0. It means one of the column has to be 0. Okay, you see in this example, we did all the work, we did all this work till we finally end up having something like this. The last row, this is in case of 3 by 3, the last row has to have 2 0. So in that case, when you have 2 0, then you just have 14z equal to -7. That would give you z. The second row is supposed to have 1 0. In that case, you just have 2 variables, see? And in this case, it just happened that the first one also has a 0 here. So these are your equation. You find the z from here and you do the substitution, okay? You could look at the lecture notes for these problems. Now, for instance, for me to do the 3 by 3, see there was one 3 by 3, they ask us to solve a system of equation using the matrix, okay? And this is what I did here. So what I do is I label all this row R1, R2, R3. Then I decide to multiply R2 by -2. See, if I multiply this by -2 and add it to this, multiply this by -2, make it -4. -4 plus 4 is 0. Okay, look. Multiply this by -2 is -4. Add it to R3, add it -4 to 4, and make it 0, which is here. So, but you have to do it to all. So you need to take all the entry in R2 and multiply by -2 R2. When you find the result, add it to R3, add it to these numbers, and that give you a new R3, okay? So look, -2 times all this would be -4, 2, 4, -8. Add it to R3, 4, 5, 6, 4. That should give you this one. See how it works? Now I try to have put another 0 here somewhere, right? So then I say, okay, if I take the first one and multiply everything by -2 and then add it to R2, like here, if I multiply 1 by -2 and add it to 2, it would make this 0. See? If I multiply this 1 by -2, add it to this 2, it make the entry 0, and that would be your new entry, new R2. So you multiply all these numbers by -2, add it to R2, and that would be your new R2 right here. So now I have 0 here, 0 here. I need at least 2 0 here. One of they are already 0, so one of these two has to be 0. In that case, I multiply. Maybe if I multiply this 3 by -7 over 3, 3 and 3 cancel, it would be -7 and add. See, I'll take -7 over 3 and multiply by all these numbers and add it to the 7. That give you the new ones. See, now I have a 3 by 3 matrix. It has 2 0 here and 1 0 at the top. So when I want to write this, it would be what? X and Y both are 0. Z, 2/3 of Z is equal to 2/3. See, Z is 1. What about the second one? Equation of the second one, if I put the X here and Y here, and Z would be 3Y plus 4Z equal -2. You already have the Z from here. You put it there, that'll give you the Y. And the first one, what's the equation of the first one? X minus 2Y minus 3Z equal to 3. So now since you have all the value of X and Y, you substitute that to find the X. As I said, the matrix of 3 by 3 takes longer to do it. But you could also, sometimes if you understand, if you go online and know how to use the calculator to also help you, at least show you whether you have the right answers or not. The rest of the problems are some word problem. Collection of 35 coins. So there are 35 coins. Let me just go to that problem here. Second. There it is. There are 35 coins. Number of dimes and number of nickels are unknown. I don't know how many of dimes and how many of nickels I have, but I know the sum is 35. It's given in the problems. So if I have 2 dimes, let's say here X is 2. If I have 2 dimes, how many cents is that? 2 times 10, which is 20. If I have 5 dimes, how many cents is that? 5 times 10 is 50. If I have X dimes, how many cents is that? 10X. If I have 3 nickels, you take the 3 and multiply by 5 because each nickel is 5 cents, it's 15 cents. What if I have 10 nickels? Would be 10 times 5. What if I have Y? 5 by what? This gives you the cent. And that also is given, is 260 in the problem. See, $2.60, if you want to convert it to cents so we don't have to deal with the dollar, you just write it like that. Now, this is 2 equations and 2 variables. The rest is a normal way. If you don't have to use matrix, you could use just a method of elimination to do this. Very easy to do. But if you want to use the matrix, that's how to do it. Okay. Again, if I multiply this by -10 and add it to that 10, that would be the new things, which is here. Number 4, a saleswoman sells a dry fruit mix, which is $5.90 per pound, and nuts for that much. And then he mixed both together. How much of each? So the question is, the last statement of the word problem will tell you what the unknown is. How much of each? Each what? One is the dry fruit mixture. We don't know how many pounds of that and how many pounds of the nuts. See, those are your questions. How many pounds of the dry food and how many pounds of the nuts? Okay. Together, there are 15 pounds is given in the problems. It said there are 15 pounds when you mix it. When you take these 2 X pounds of this and X pounds of this and Y pounds and mix it together, that would be 15. Okay. And then the price is given is very similar to that. You know, the other ones, you take the dime multiplied by 10 cents. For here, dry fruit is $5.90. So you take 590X. Nuts is 14.55. You multiply that. And they're telling you when you mix it here, this mixture, which is 15 pounds, because you bring some from here, some from that, and $2, 15 pounds. This mixture, they sell it for $9.36. So if you multiply that, that would give you the price here. And then these are 2 equations and 2 variables. The rest would be just a matrix. Number 5 is just 2 by 2 matrix the same way, and number 6. So that shows 2 more problems of how to apply the matrix. See, we're trying to have the entry for one of this. So these are very similar, and you could do the process. Okay, there was 6 problems here assigned.